My name is David Klebanov. I'm a leader in Cisco SD-WAN technical marketing organization. I came through the Viptela acquisition. Ramesh and I spent many wonderful years back in Viptela. So today we're going to talk about a couple of topics. We're going to be double-clicking, just like Ramesh and Rohan mentioned in the beginning. We're going to be double-clicking on several items. So there are some foundational things that I wanted to make sure that we are all sort of in agreement on. And if you have any questions, then obviously feel free to ask me anything that comes to mind. iOS XE SD-WAN is one of those foundational things that we want to cover today because it's a foundational element of some of the things we are going to double click on later on in regard to cloud, in regard to security. So I want to make sure that we understand sort of the premise behind iOS XE SD-WAN. What is iOS XE SD-WAN? And how do you migrate to iOS XE SD-WAN from what you have today, right? Obviously, it's a very loaded topic. Migration could take hours just on its own, so we won't be able to cover all of that. But at least we'll give you a flavor of the art of possible, what you can do with iOS XE SD-WAN. So that's going to be our kind of three topics for today. First, we're going to talk about kind of the architectural recap, because my session is kind of the first one that is generic to some degree, right? We're not going to be kind of heavily double-clicking into cloud and security. So I'm going to spend maybe a couple of minutes to just setting the baseline of what Cisco SD-WAN architecture is and what are the elements of Cisco SD-WAN architecture in case some of you need a refresher, right? So we'll call this as a recap. Then we're going to talk about those migration best practices of how to adopt Cisco iOS XE SD-WAN. And then I'm going to give you a brief demonstration of some of the operational elements that we're improving in our Cisco vManage platform, which is our single pane of glass for the entire SD-WAN solution. Okay, so as an architectural kind of recap, we are an SDN system, so we're very firm believers in software-defined networking principles, which identify three distinct architectural tiers of data plane, control plane, and management plane. And that's exactly how our solution is built day one. If you kind of follow from bottom up, on the bottom you have a collection of WAN edge devices. These come in different shapes and forms, physical, virtual. We're going to have a slide after this one just to recap what are different platform capabilities. But these are the traditional V-Edge appliances, physical or virtual, that we brought into Cisco from Viptela. These are also the Cisco routing platforms, the ISR 1000, the ISR 4000, the ASR 1000, the CSR, virtual routers. So it's a whole slew of platform choices that our customers have when they sort of embark on this Cisco SD-WAN journey, right? We also see this WAN edge as being critically important for the features such as multi-cloud and on-ramping into the cloud. That all happens from the edge. The security features, which is pushing the security into the perimeter of the network, because the closer security it is to users, the more efficient it is. And the application quality of experience. So we're not going to spend time today talking about application quality of experience, but think about this as you build this entire architecture because you want to transport applications over it. So you want to make sure that the quality of experience for applications, be those on-prem applications or a cloud applications, is as best as it can be, right? So these are kind of three key services anchored on the data plane. Now the data plane talks to the cloud, and the cloud is a collection of controllers of different types. The first one is the vSmart controller, which is the control plane controller. It's used to really establish the fabric to distribute control plane context around in regard to routing, security, different attributes. It runs our overlay management protocol, which is an extensible control plane protocol that runs over certificate authenticated TLS or DTLS connections that get established in a zero-touch fashion between the routers and the vSmart controllers. So vSmart controllers live in the cloud. We're going to see what are the options where that cloud could be. And then at the end, you have the vManage, which is the single pane of glass. That's what you would expect from sort of a system where this is the place you go, this is your GUI, this is your APIs that you can leverage for any programmatic work, any scripting, anyone who wants to kind of do things with Python scripting and make REST API calls to automate some of the workflows inside vManage beyond what the graphical user interface gives you. And we have kind of a growing interest from the community to do kind of all of those DevOps things on top of vManage. So these are the three distinct layers of the solution. In addition to that, we have the layer of analytics, which takes the telemetry from the network and basically analyzes that, provides this sort of a predictive analysis as to capacity planning, capacity forecasting, some performance baselining, things like that. We purposefully separated that from the vManage system because it requires a little bit more of that sort of a compute power and analysis rather than just vManage as being a pure operations tool when you go provision things, troubleshoot things, deploy things, things like that. So it's separated into a different system. It's an optional element, but we have a really good traction around customers adopting analytics platform. So that's kind of like a refresher for you guys to keep in mind where what Cisco SD-WAN is and what are those elements of it. Now, I mentioned platforms, right? So our customers have a wide variety of platforms they can choose from, right? So if I go, again, physical platforms, choices of either ISR platforms or the traditional Viptela vEdge appliances. Those are the physical platforms. So many of our customers would prefer to consume this technology in the form of an appliance, a router. It's more predictable, more recognizable to the network teams. They have operational procedures around that. So they don't want to disturb that. They want to continue consuming that in a physical form factor. And for that, they have a choice of platforms. Obviously, because we're talking about iOS XE SD-WAN, we're going to be focusing in this session on the Cisco ISR and ASR platforms, which actually run the iOS XE software. Now, for some of our customers that want to deploy this in a completely virtualized form factor, they're free to deploy our software on top of any x86 platform, or they can deploy this on top of our ENCS platform, which is Cisco gray box solution. It's an x86 platform, which is also a router, has a management on it, runs hypervisor, KVM-based hypervisor. So it's kind of like a little bit friendlier than just a generic x86 server, but our customers have a choice of whether they want to run this on ENCS or just a plain vanilla any x86 server. And we reach into the public cloud by offering the instances of virtual routers in three major cloud compute environments. So that's kind of the lay of the land as far as what is your kind of a menu of choices that the customers have. Now, obviously, many of our customers are ISR and ASR customers. Just like Rohan mentioned, millions of routers are out there. A lot of interest is how do I take those routers and move from a traditional routing box-by-box paradigm into an SD-WAN paradigm, which is a network solution, which is a system centrally managed with a cloud-based control plane, all of these things, right? And for that, the iOS XE SD-WAN is really the driver behind it. Question? Any support for the CSR 1000V? Yes. I'll go back a slide. So CSR 1000V is formally being supported in our release that is going to be coming end of November. Okay. So we have a code release that is going to be end of November. We call this 1610. And that is where we will support CSR running iOS XE SD-WAN. Okay. Thank you very much. You had a question?
Is there a functional difference between running the solution on ISR platform than on a vEdge 1000, for example?
Excellent question. Yes, there is. And that's a good segue to this slide, right? So what have we really done with the XE SD-WAN, right? So think about an XE SD-WAN as a foundational piece of software that runs on top of the Cisco iOS XE routers, ISRs 1000, 4000, ASR 1000. So what we've done is we have embedded a Viptela brought components, Viptela intelligence, Viptela services into the iOS XE SD-WAN. Now, did we keep an iOS XE SD-WAN? Sorry, did we keep an iOS XE in its entirety? No, we did not. Many of the services that exist in iOS XE are not fully compatible with the way that SD-WAN operates. Many of the services are not largely adopted. So we took this sort of like an approach of, okay, let's prune things so that we don't feel are compatible, because SD-WAN is not just a router by router solution. It's a system. And as a system, it must operate as a system. So we can't just have quote unquote sort of rogue functionality that some of it is controlled through vManage, some of it you have to log into the router and configure CLI or use some other management tool. That does not work. It has to be controlled by vManage, right? And as such, we decided on which elements of a traditional iOS XE will make it into the XE SD-WAN and which ones we decide to introduce at a later point. So there is not 100% feature parity between iOS XE SD-WAN and the traditional Viptela operating system. And there's obviously some services from the traditional iOS XE that we also took out. So there's some considerations that customers go through when they convert their existing routers into the iOS XE SD-WAN routers. And it's an evaluation process in regard to what am I gaining by getting SD-WAN features, and what am I quote unquote forfeiting by removing some of the things that we decided not to include. But as you can see in here, we kind of sprinkled that Viptela intelligence within the iOS XE SD-WAN code, right? And some of the key things that we brought from Viptela are obviously in here, and particularly the overlay management protocol is in here, our communication to the management system through conf-d and basically netconf communication. Obviously things that have to do with all the SD-WAN policies. And yet, side by side, we kept some of the really solid, proven iOS XE features in there, right? As you can see, there are different buckets in here. So security is a bucket of feature functionalities embedded in iOS XE SD-WAN. We have things like services. Obviously, this is not a representative of everything inside the iOS XE SD-WAN, but just so you understand that it's kind of like taking an iOS XE SD-WAN, sprinkling those Viptela components in them embedded. So it's not running as an external foreign entity as a container or whatnot. It's embedded inside the iOS XE image.
You mentioned that there's some features that from the traditional Viptela platform that wouldn't make it in. So you mentioned that.
Right.
And you didn't specify. I'm curious to know, but maybe this isn't the right time.
Right.
Is there anything in the what we would be familiar with in the iOS XE code that is now gone when you would upgrade to the?
Right. So you had two questions. The first one is what do you lose from the traditional Viptela? So 15 months into acquisition. Obviously, it's a very tremendous amount of work that goes into introducing the traditional Viptela features that we had developed for years into the iOS XE SD-WAN code, right? So it takes time.
Yeah.
So there's a certain roadmap of when the features that existed on Viptela, we have 75% of them already in XE SD-WAN. There's a certain amount of features that are still trickling into the iOS XE SD-WAN. You will have a complete full parity between what you had before and what you have after. Yeah. So that's just a matter of short time. Okay. The second question about what features of iOS XE traditional one you lose, quote unquote, by converting that to iOS XE SD-WAN. So there's some things, for example, the whole slew of IPVPN technologies that exist in traditional iOS XE, like DMVPN, for example. Not there anymore. We have our own mechanisms.
Okay.
Right. So things like that, right? And some of the things that did not make it to the XE SD-WAN initially are going to be introduced into the XE SD-WAN. Again, it's a factor of time.
Yeah.
Some of the customers are using the ISR, especially in the SMB market for routing, UC, etc.,
Yes.
etc. Is UC going to be part of that code as well, or?
Absolutely. It is not there today. We have, I'll talk to you about when we talk about the migration. Today, if you were to look at the iOS XE SD-WAN, it does not have those traditional voice features such as, SRST functionality, PRI termination for local voice breakouts at the branch offices. We see a tremendous move specifically for UC. We see a tremendous move into SIP-based communications, in which case it's all basically just network. Right? And building a better network gives you a better, unified communication experience. As long as, and we have many customers who are kind of departing from the traditional way of thinking about, I have to do PRI circuits, FXO, FXS circuits, I have to make sure that I have SRST because my WAN can go down. By building a solid WAN, many of those things just disappear on its own because now I have a fully redundant WAN that never goes down, right? I don't need an SRST functionality in it, right? Do I need a PRI breakout? Well, no, I'm moving into SIP-based trunking. Right? So many of those voice-specific things are actually not needed in the world of 2018. Sort of true.
Because you leave some customers in a pickle because there's school districts and hospitals and stuff that need a tremendous amount of analog backup. So you can't just move away and say,
for sure.
I agree with you as far as what you're saying, the spirit of what you're saying.
Right. And it's a fair point, right? So keep in mind, it's a matter of time until the things that are not there today are going to make it into iOS XE SD-WAN. For that, we have our, our customers, our product management team that works diligently on making sure that these things make it back.
Yeah.
Again, 15 months into acquisition, we've done a lot.
Somewhat related question. In a few of the other sessions that we've had, surrounding SD-WAN, we've been wondering about multicast as a feature. Is that going to be included with it?
Yes. So multicast is a long-standing feature that we had from Viptela days. Multicast, again, it's one of those features that is not there today on XE SD-WAN. And again, just like I mentioned about voice, it's going to make its way into the XE SD-WAN. Obviously, the traditional XE has a very solid implementation of multicast. It's just a matter of making sure that that is brought into the SD-WAN domain under the vManage management, vSmart controllers. So it's a matter of time. Absolutely, our plans are to have multicast as part of the iOS XE SD-WAN. So good questions. Let me move a little bit further around migration sequences. So the customers who are adopting iOS XE SD-WAN have to plan how to get on board XE SD-WAN, right? Some of those are easy. Some of those require a little bit more kind of considerations, right? So we typically see that adoption having 3 phases. The first one is obviously establishing the controller footprint. This is 95% of our customers opt for cloud controllers. We have a fully automated cloud ops operation that spins up all this control infrastructure in our public cloud backend. So that's not something 95% of our customers ever have to get involved with beyond placing an order. You place an order, magic happens, controllers are spun up. So nobody needs to do anything about that. What the customers really focus on is transitioning data centers, and more importantly, introducing SD-WAN into an existing data centers, and then performing the actual migration on the branches. That's primarily where the bulk of the sort of the work goes into, right? Obviously, everything is zero touch, but there are some certain considerations that you keep in mind. So if we look at controllers, controller deployment, as I said, fully automated when it's deployed inside Cisco Cloud by the Cisco Cloud Ops team. Customers have a choice to deploy this in their own data centers. A small subset of our customers that have some compliance or regulations that require them to host their own control infrastructure, they absolutely do that in their own data centers, works equally the same. And we have an opportunity for our partners to deploy and host and manage those controllers in their own clouds. So their own data centers, their own colo facilities and whatnot. So we have a slew of partners that basically see that as an opportunity for them to provide value-added services into the customers. Whatever the case may be, those are all virtual elements. They can live on any IP cloud. Customer cloud, Cisco cloud, partner cloud. Now, if we talk about data center deployment usually revolves around topology that looks like this, when an SD-WAN intelligence, and in this case, we're talking about iOS XE SD-WAN, but it equally applies to the traditional Viptela operating system and traditional Viptela routers as well. So we're making kind of an emphasis on iOS XE SD-WAN here, but equally applies to the vEdge routers and the Viptela operating system as well. These routers are inserted in a manner that is sort of like sandwiched in between the data center core and the front-facing layer of MPLS, which is the MPLS CE routers and the firewalls that front-end the internet connectivity that already exists in the data center today, before even started SD-WAN adoption. Right? So it's kind of a typical topology of the data center. There are certain advantages of why that's a typical architecture. We're going to double click on some of them later, so I don't want to linger too much. But data centers are usually very straightforward. It requires, obviously, very comprehensive support for routing protocols, which we have. Because unlike branches that tend to be simpler, data centers tend to be more complicated. So obviously, you have to make sure full support for routing protocols, OSPF, BGP. Before somebody asked about EIGRP, yes, we're adding EIGRP. But today it's OSPF and BGP. And obviously the interaction between the core switches, the MPLS CE routers, so it's all kind of embedded into the data center routing topology.
So you are talking about, David, OSPF and BGP as an underlay, because as an overlay you have OMP, right?
Absolutely, yes. Absolutely right. Overlay cannot live without underlay connectivity. I need to have a foundational IP connectivity before I can establish any tunnels, any control connections. So absolutely right.
For the migration scenarios, EIGRP for the underlay would be necessary.
Very fair point. Very well taken. Yes, EIGRP is out there a lot. So we will be adding that. In the meantime, there's ways to do redistribution between OSPF and EIGRP on the core switches. So there are ways around that. Matter of time, EIGRP will be there. If we look at branches, right? So let me run through a couple of quick scenarios about branches. So a branch that looks like this, it's a simple branch that has a single router, no redundancy, connected to an MPLS circuit, has potentially maybe a LAN switch that is doing layer 3, again, OSPF, BGP, or it's just a layer 2 connected subnet, really simple, maybe some layer 2 switches sprinkled around. What we do in that case, and the simplest one, is to perform a software upgrade. Again, it's a compatible platform, so it's one of those platforms that a customer already has in their branch. They just do a simple software upgrade. Load the software, reboot the box, comes back up, all the control plane stack comes online, which means talks OMP to the controllers, talks netconf to the vManage system for management, interfaces with the southbound routing, if there is any, right? Performs potentially redistribution between OSPF, BGP into OMP to advertise that out into the rest of the overlay. So this entire sort of control and management stack just comes online, zero touch, right? So the amount of effort that went into this is performing a software upgrade, right? Again, it's an opportunity to also diversify the connectivity. So if there was an MPLS circuit, keep it. If you want to augment an MPLS with internet, add an internet. Some of our customers add 4G LTE. Some of our customers discontinue MPLS circuits in some sites. So it's a complete sort of freedom of choice as far as which transport is chosen.
Will you continue to keep OMP, or for the overlay, are you considering to?
Oh, it's a very good question. Would we consider to have an OMP or continue with OMP? Absolutely. OMP is the coolest thing we have. It's a really foundational protocol within the SD-WAN fabric. It's far superior to any other control plane mechanisms that we've seen out there.
What about interop then?
Interop. We can talk about that. Interop, the way we see that is happening on the southbound. The fabric itself, the core of the fabric, has to be compatible with our sort of control plane, right? Well, it's a good point. Potentially, opens a good opportunity. Actually, one of the first days at Viptela, I actually asked why is there not an RFC for OMP. So it's a good opportunity to have one. The next one is very similar, and we're talking about redundancy in this case. So a site that looks like this, which basically has two routers, right? And one router is connected to MPLS network. The other one is providing some backup connectivity through some sort of an IP VPN technology. Could be any flavor of VPN technology, DMVPN, GetVPN, whatever VPN, XVPN technology that customers deploy. Very popular design of active standby approach. Active MPLS, everything goes to MPLS, backup is IPVPN, some sort of a first hop routing protocol in here, HSRP, VRRP, whatever the choice is, or potentially layer 3 switch with OSPF and BGP. Pretty straightforward. The migration into XC SD-WAN is as simple as the case before, is that both routers upgraded. Obviously, there is a way to do this one by one. My personal recommendation is to make it simple. The simpler, the better. take a downtime on that site, schedule a maintenance, upgrade both routers, let the control and management stack come online, have that site fully migrated into SD-WAN. We're going to talk in a few minutes what happens to backwards connectivity to non-SD-WAN sites, but leave that for a second. The actual site itself, software upgrade in both boxes, and again, first hop routing protocol, VRRP today, and OSPF BGP, nothing really changes, right? It's the same philosophy that you had before, just now under the control and management plane of SD-WAN.
So I'm going to be very transparent with you with this question. Upgrading code on production routers, especially big chassis switches and that sort of thing, scares me.
Sure.
Not because it's not necessary, but because it doesn't work all the time, and it's 2 o'clock in the morning in a data center. I hate doing it. I do it. I hate doing it. Are you seeing a lot of just great success with upgrading the code to the iOS XE SD-WAN code and no significant issues?
So I share your concerns. I was a network engineer many years ago. But
Production today?
is it simple? Oh, okay. So the upgrade, the before.
Well, that's a good question.
So the upgrade process itself is not dissimilar from a traditional router upgrade, because the before is no SD-WAN present yet. So I have to use my existing tools. However, I upgrade my routers. Does that bring in USB stick and plugging it to the USB port, copying the file into boot flash, changing boot parameters, and rebooting? Maybe I want to do TFTP and upload this to the boot flash, reboot. So however I do this today, the before is however people do this today. Once it's upgraded, then the control and management stack kicks in, and then I have vManage to do any subsequent upgrades within the SD-WAN. Now, I agree to your point. The only thing I can say is that there's an operational discipline, file the change control, doesn't work, roll back.
Yeah, okay.
Right, so there's very little to be said about that. It's a software upgrade, with all these sort of things that come with it. If it's successful, and I'm very confident that it will be successful. But if something goes wrong, you roll back. That's what you have the maintenance windows for, right? So there are design scenarios, which unfortunately we don't have time to talk about, that are more complicated and actually run the SD-WAN and non-SD-WAN intelligence at the same time. So you can be sort of like both, both worlds, and you can say, was that successful? Was it not successful? I still have connectivity if it's not successful. So maybe shortens the maintenance window, less interruption. We have those designs. We'd love to engage with individuals that want to learn about those designs. Obviously, they're a little bit more complicated, require more skills around routing and interoperability between overlay and underlay. So it tends to be more complicated, doable, but tends to be more complicated.
Are you planning to release a migration guide where clients using I1 with ERJP and DMVPN wants to move to that, because that's going to be...
Good question. Yes. There's a slew of Cisco validated designs we're working on. It's a work in progress. Specifically for a software upgrade, we already have a lot of resources. There's a document that describes how the migration occurs, not a migration from a system like I-WAN into a system like Cisco SD-WAN, but more like how do you perform an upgrade. There's video recordings about this. So for that specific piece of a software upgrade, we have that out there in our documentation and YouTube channel. But as a system migration from this to this, I'm going to touch on that in slide or two. But CVD is a work in progress to exactly accommodate all of those scenarios. Migration tool, yes, this is a good, thank you, Ramesh. Yes, so for configuration migration, we have a tool that basically you input your existing configuration from the copy-paste, your existing configuration from the router. Then you can link it into your vManage instance. It basically analyzes the configuration, says which lines of config are not compatible with SD-WAN. It's going to flag those, and it's going to ask you to remove those. And then after everything checks out from the config, it will actually reach out through API calls into the vManage and create all the configs inside vManage. So there's a config tool that helps with that transition.
You said that we have to copy-paste.
Yes.
There is no way for the tool to connect directly to the router and,
Not today.
and check the configuration.
Yeah, today it's a very fair point. Working on it, but today there's no.
It's the day of automation and
Right. So the thing is with traditional router, you either have to SSH to it, and then suck the config and analyze it. So it's possible. But today that config tool is taking a little bit more of that sort of manual approach.
But
you as an administrator.
It's a direction that you will.
Absolutely, yes. Yeah, the idea is to explore the direction of quote unquote like sucking the config out of the existing router, running through the logic, analyzing, spitting out vManage templates.
Okay, thank you.
Sure. In some of the cases, we have routers that are either a managed router, which is this gray out guy. Actually, it's this to begin with, right? It's a managed router. You can't really upgrade that because it's managed by a service provider. And they may not offer Cisco SD-WAN as a service, but you still want Cisco SD-WAN as a service. So you keep the managed router and you build SD-WAN on top of that. Right? That's one option. The second, there could be some unsupported feature that would prevent you from upgrading this router, such as voice, for example, today. Or there could be things like underlay backup, which is kind of an advanced topic. So what you do, you basically don't touch that router. You add a router. It's an additional box that you add into the site to keep what you have today. And you add an additional iOS XE SD-WAN box into it, and that box will build an SD-WAN fabric on top of that. It's a very corner case, couple of ifs, and if those ifs exist, then you have no choice. And that your solution is to add an SD-WAN intelligence side by side to your existing router intelligence. Not my first choice, but if you have to do it, potentially.
That's a transition strategy, though. You
set
up the SD-WAN fabric and you slowly start moving traffic over.
You can do that, yes. Yeah. But I share your facial expression that it's not the best. But when you have to, then you have
scenarios where that's really what you're going to need to do because of reasons. Yeah.
Sure. Yeah. I'm not going to touch on that, but virtual branch, I touched on that in the beginning. Fully supported ENCS or any x86 box. Just load the VNFs on it. You can do Cisco plug and play to bring it up in an automated fashion. So in case it's ENCS, right? ENCS and the SD-WAN VNFs on it. Potentially you can add additional VNFs, such as WAN optimization VNF, firewall VNF, whatever VNF you want to add that. It's a virtual branch solution, right? As far as the interoperability is concerned, we really see data centers is the most optimal way to perform that interoperability. And that basically boils down to routing. You advertise SD-WAN subnets into the underlay. You advertise the underlay subnets into SD-WAN. You perform the redistribution of the two in the hub site, which is the data center. And a data center is kind of built like this. Data center core, MPLS-C routers facing the MPLS. Oops, apologies. SD-WAN routers, SD-WAN headends facing the SD-WAN fabric. So we tend to look at that as a transition hubs. Many times these transition hubs are data centers, and that's where the overlay and underlay meet. There are designs where overlay and underlay can meet at every single branch. So I have every single branch that can do overlay and underlay to an MPLS site. Not something that we advocate. We've seen a fair share of issues with that, starting from the routing loops, every branch office becoming a transit site because you didn't filter the routes properly, turns into an ECMP problem. How do I reach that other site? Oh, it's 100 branch offices that can take me there, which is not true. So whole slew of things that could happen. So we really see those data centers and those hubs to be sort of the anchor point. Now,
so how are you handling this? Is the hub, is it just routing?
It's just routing.
Okay, so there's no magic tools or anything that's going to make this easier for me.
Is
this more like a Cisco validated design?
Right.
Hey, set up your routing like this to solve these
Yes,
problems.
exactly.
Like when you had DM, EPM with EIGRP stub feature or OSPF, maximum metric router, let's say. So,
yeah, it's basically two worlds meeting at the data center core, right? Now, for those customers who are a little bit more geographically distributed and are saying, I like this approach, I like the way that you are kind of safeguarding me from shooting myself in the foot, but I'm very distributed. And you're asking me about data center. Can I use multiple data centers? Of course. So we have some customers that have done this in a distributed fashion when they have geographically distributed data centers, so Americas, Europe, Asia. And again, routing tricks to make sure that we attract the traffic from a specific region into the local hub symmetrically from both SD-WAN and the MPLS. Right? Again, it's a little bit kind of a more involved design, but comes down to just basically routing interaction between an overlay and underlay. So those capabilities around routing protocols and a mature routing protocol support, field-proven support, it's critical in this case.
Is it like prefer this path over this path, then I think vManage arranging the higher OMP preference, or user needs to know that higher number with the OMP is the best path?
Right. So when you are in SD-WAN world, you operate by the SD-WAN rules, which is exactly the OMP preference. And really, this one says to draw the traffic that I'm trying to keep this within the region. I have this hub, which could be the European hub, and I'm trying to stay within Europe, right? I'm trying to say SD-WAN region in Europe and SD-WAN or an MPLS region in Europe. I want them to stay within Europe, right? And that's exactly what it's doing, is that it's setting the higher preference for the subnets in the MPLS region down. And
that's actually my question. So do I need to set the higher preference, or can I just say a fraction that traffic should stay, let's say, on
Sure. So it's a good point. Today within the tool, it's down to the administrator to actually set the proper configurations and policies to make sure that it happens. There is no tool that we offer that does this magically for you. There's potentially an opportunity for somebody to write an API calls that would execute on a logic like that. It's nothing more than a logic between templates and configuration templates and policies to make sure that you execute on this. There's no voodoo magic in here. It's very straightforward networking, right? So if you're a network engineer, you understand how routing works, you could execute on that. Okay, so I do have it. I'll skip on that one. But I do have a demonstration to show you. Maybe I will take 1 minute to show you this. From the configuration standpoint.
Can we see an upgrade?
Everybody will be.
You can, if you have a 15 minutes not to do anything. But yes, we actually have videos out there that outline the whole upgrade process. It has a lot of hits. Hamza is one of the presenters in that video. Him and Nikolai, they teamed up on that. There's a video on YouTube. You can watch it. 45 minutes, I believe. 30 minutes, yes. And it walks you through prerequisites, configuration tool, and the actual upgrade itself. Not really fun. The actual upgrade itself is really nothing but loading an image, rebooting, and waiting.
Yeah.
Everything else, once it's SD-WAN device, logic kicks in. It's governed by the SD-WAN rules. Everything is centrally managed through vManage. So one thing I wanted to quickly show you is, okay, so this is the vManage, right? If you haven't seen one, this is the management tool, right? So one cool thing that we're doing is many of our customers, they're kind of simple customers, so they don't look for a lot of complicated way of doing things, right? So we said, okay, how can we simplify life for the easy deployments, right? I just want to spin up a couple of, or maybe a lot of sites, but they're really simple. I'm not looking for anything extra elaborate or things like that, right? If I want to do those like crazy things like regional hubs and things like that, obviously I need to be a little bit more involved. But if I'm just trying to spin up something simple, so how can I do that? So we have a really simple thing in here that we call a network design. So when I log into this, I can create, basically this tool allows me to visualize my configuration of the network. So clouds are my transports, and then I can go into the managed network. I can say I want to add a branch, and I can say this is redundant branch, and I can say this is my private router profile, And I can say what type of the router that is, and these are all the routers we talked about. And I would say which circuit it's connected to. So this is going to be connected to MPLS. Great, I want to add another profile, and I want to call it a public router profile. I will choose the same type of router. There it is, and say this guy connects to the public network. And obviously I messed it up. Okay, but I would have, if I would have saved that, basically what I'm doing in here, I'm creating this flow of templates, or sort of the configuration of the templates. But instead of me sort of going and defining things in more detailed way, I just have this really simple flow of defining what the router is, which VPNs are in there, which interfaces are in there, and it's all kind of a wizard-driven, next. At the end, it saves it, and you can apply this configuration onto the routers, right? So one of the operational enhancements that we're doing within the vManage that really streamlines the simpler deployments. Okay, I'm getting the sign.
Can you do all of this programmatically?
Absolutely. Excellent question. Everything you see on this GUI can be invoked through REST API calls. Anything. So we have some customers that have an appetite for doing that. Absolutely. You can automate anything that is beyond what you see in here. You don't like the way we do it. You want to do it your own. You have your own GUI. You have your own operation portal that you have for your ops team. Be my guest. Have another website with Python scripting and API calls.
Is your GUI an API consumer?
Absolutely. The API, everything we do in the GUI is basically the same API calls that you can make to the vManage server.